Kia ora koutou katoa, it's Mrs. Goodson here, and this video is about reactions of alkenes. It's part of organic chemistry, and the learning intentions of this video are to identify the reactions that alkenes undergo and be able to draw the products of addition reactions, and to use Markovnikov's rule to identify the major and minor products in unsymmetrical alkene addition reactions. Also to explain how oxidation and halogenation can be used to distinguish between alkenes and alkanes. So those are the learning intentions of this video. The chemical properties of alkenes means what reactions do you need to know that they undergo. The first one is combustion, and that's very similar to the alkane reaction. Then there's addition reactions. There's hydrogenation, which means adding hydrogen gas. Halogenation means adding a halogen to the alkene. This can either use HCl, HBr, Br2 or Cl2 or other halogens. Hydration is adding water to alkenes. Oxidation means adding oxygen, and this can be done with a strong oxidizing agent, permanganate, which is colored purple. Polymerization is making polymers. Polymers are really large molecules made up of small repeating units. These include lots of organic molecules such as starch, wool, DNA, and synthetic products like plastics. Making polymers is going to be covered in another video. Combustion reactions of alkenes. The complete combustion of oxygen requires plenty of oxygen and results in carbon dioxide gas and water as steam. And it's very similar to the alkane combustion. So you take ethene and oxygen gas and it makes carbon dioxide and water. Alkenes also undergo addition reactions. Alkenes have an unsaturated carbon-carbon double bond that can undergo addition reactions. This is the definition of addition reactions. They involve breaking a carbon-carbon double bond to make a single carbon-carbon bond and two new single covalent bonds. In this example, you will see we've got an alkene and we're going to add HCl. So this double bond gets broken, this double bond, and two new bonds get made. So one that gets made is with the chlorines. There's no chlorines on this one. The chlorine comes from the HCl. Also another hydrogen. So this carbon had two hydrogens and now it's got three hydrogens. So it formed a single bond between the carbon-carbon atoms and two new covalent bonds. So this is the first addition reaction we're going to look at, and it's when you're adding hydrogen gas, H2, and it adds it across, we say it adds across the double bond. Now to make this reaction happen, it requires a catalyst, either nickel at 150 degrees centigrade or platinum at room temperature. So you need to learn the conditions for this reaction, as well as learning that you can add hydrogen to ethene in this example, but to a carbon-carbon double bond. And it creates, and you can see the hydrogen is here. So one hydrogen adds to this carbon and another hydrogen adds to the other carbon. So that's hydrogenation. The next addition reaction is halogenation. So that adds one or two halogen atoms to the molecule. So if it's Br2, it's going to add two bromine atoms. Cl2 is going to add chlorine. HBr is going to add hydrogen and bromine, and hydrogen and chlorine. So this reaction can be used to distinguish between a carbon-carbon double bond and a carbon-carbon single bond. It's used to test for unsaturated alkenes because the alkanes would only have a single bond, react slowly, and require UV light. So we use bromine, Br2, And bromine is a brownish red, sometimes we say orange color. And when it gets added to a carbon-carbon double bond, it forms a colorless haloalkane. So the color goes from brownish red or orange to colorless. And that is a test for whether it is a carbon-carbon double bond, unsaturated, or a carbon-carbon single bond, which is saturated. The final addition reaction that you need to know is adding water or steam. Now this makes alcohols, because what happens is that one of the hydrogens from the water joins here, and the OH from the water, you've got H2O here joining across the double bond. Now it requires heat and pressure and an acid catalyst. So you need to say that it's heat and just put H plus for acid. So those are the conditions that this reaction happens. So you've got ethene plus water. This applies to all alkenes. This is just our example is ethene, and it makes ethanol because it's got an OH group, 2 carbons, ethanol. So if we've got an unsymmetrical alkene, then it actually makes 2 products. There are 2 possible products. And deciding which one will be the major product, we use Markovnikov's rule. Now, to identify the major product, the hydrogen atom from the HCl will bond to the carbon atom in the double bond that already has the most hydrogen atoms bonded to it. So in this example, we've got 1 butene, and this HCl is going to add, and it's going to add across this double bond. The hydrogen will add to one of them, and the chlorine will add to the other. So we get 2 possible products, depending on which carbon the chlorine adds to. So if the hydrogen adds to carbon 1 and the chlorine adds to carbon 2, this will give us the major product, which is 2-chlorobutane. Okay, so this hydrogen is adding to carbon 1 because carbon 1 has 2 hydrogens and carbon 2 only has 1 hydrogen. So this is the favored reaction. This will happen more often. So this becomes the major product with a hydrogen on carbon 1 and the chlorine on carbon 2. And so that's 2-chlorobutane. That forms our major product. But it also, the chlorine could add to carbon 1 and the hydrogen add to carbon 2. So that would form the minor product. That's because the hydrogen is adding to carbon 2, which has got the least number of hydrogens. So it's least likely to occur. So that forms 1-chlorobutane with the hydrogen on carbon 2 and the chlorine on carbon 1. Okay, so if you've got 2 carbons of the double bond that have different number of hydrogens, we say it's unsymmetrical and there are 2 possible products. The major product will be when the hydrogen adds to the carbon that already has the most hydrogens. Okay, so this is a practice question. I want you to draw the 2 possible products from addition of H2O to 1-butene. So the hydrogen will add to the carbon that already has the most carbons. That will form the major product. And the OH will join to the carbon that has the least number of hydrogens. And then you swap them over and that will give you the minor product. So I want you to pause the video now and draw the 2 possible products from addition of water to 1-butene. Pause it now. Okay, you're back from writing the answers. So the major product will be where the hydrogen joins to the carbon that already has the most hydrogens. So carbon 1 has 2 hydrogens and carbon 2 has 1 hydrogen. So the major product will be formed when the hydrogen joins to carbon 1 and the OH, or the hydroxyl group, joins to carbon 2. And that molecule is called butanol. So that's the major product. Did you get that right? And then, of course, the minor product will just be when they're swapped over and the OH group is now attached to carbon 1. So that forms butanol. There's another question for you. When HCl adds to 2-butene, only one product is possible. Why is this? What is the product it forms? Pause the video now and have a think about it and write the product, draw the product out and state the reason why is only one product possible. Pause the video now. Good to have you back from the pause. Okay, so the two carbons of the carbon-carbon double bond have the same number of hydrogens. This one here, carbon 2, has 1 hydrogen, and this carbon here has 1 hydrogen. So they are not unsymmetrical. They're actually symmetrical. There is only one possible product because it doesn't matter which carbon the hydrogen is bonds to or the chlorine bonds to, they're going to be exactly the same. So this is carbon 2 here. If we count from this end, 1, 2. But if we count from this end, 1, 2, 3, it's also carbon 3. So because the molecule is symmetrical, there's only one possible product. Now, the final kind of reaction that alkenes undergo are oxidation reactions. Oxidation is the gain of oxygen, and we're going to look at oxidation reactions later when we talk about redox reactions. But for organic chemistry, you just need to know that alkenes undergo oxidation with permanganate, which is purple, and that is a strong oxidizing agent. So when permanganate oxidizes the alkene, itself is reduced and it goes from purple to brown and it forms manganese dioxide. However, if we do this reaction in acid conditions with an H+, and we just put the H+ there, then it will go to colorless. And this is more likely that we do it under acid conditions. So it goes from purple to colorless and forms Mn2+ ions. So when we write the organic chemistry reaction, we can just put the inorganic things, reagents, over the arrow, and we focus on drawing the organic reactant and the organic product. Now, when we do this reaction, what forms is a diol. It's got 2 hydroxyl groups, one here and one here. So in this example, ethene goes to ethane 1,2-diol. And it is also used as a test to distinguish for the presence of double bonds because alkanes will not oxidize, okay? So it is another way to test for unsaturated molecules. And that is the end of our video.